Okay. February, March 2018, paper 1, variant 2. Question 1. Student is asked to find the volume of a small, irregularly shaped piece of rock. He has the following apparatuses. Which apparatus must the student use to find the volume? He needs to find the volume. Do I need the balance? Finding the volume. Do I need the balance? No, I don't need the balance. I do not need the ruler. I only need the measuring cylinder and some water. Okay, yes, D. Question 2. Um, which statement describes the motion of a car? Of this car, we have a speed time graph. Speed time graph. What's happening to the speed? Yep. What is happening to the speed? Initially, the speed is increasing. Initially, يا شباب, the speed is increasing. You cannot say that it is decelerating. No. Initially, the speed is increasing. It was zero. It kept on increasing until it reached some point, some speed. So initially, the speed was increasing from zero to the maximum speed. And then at this point, did it stop moving? Did it stop moving at this point? No, it did not stop moving. It was moving with a constant, constant speed. But this part is a constant speed. But it accelerates and then it reaches a constant speed. It accelerates. This part, can I say it's a constant acceleration? No, it's not a constant acceleration. Okay, this is a non-uniform acceleration. We call it a non-uniform acceleration. That's it. Yes, it is curving. It is accelerating. Okay, but with a non-uniform acceleration. Okay? Okay. Question 3. An athlete runs 300 meters up a hill at a steady speed of 3 meters per second. Then she immediately runs the same distance down the hill at a steady speed of 6 meters per second. What is her average speed for the 600-meter run? Okay, average speed. We know that the average speed is what? Average speed equals total distance, صح? Total distance over total total time. Do I have the total distance? Yes, I do have the total distance, 600 meters. Yes, I have the total distance, which is 600 meters. Do I have the total time? No, I do not have the total time. How can I find the total time? I need to divide it. Okay. Oh, I actually need to divide this race into two parts. Okay. The first part and then the second part. The first part, I can find the time. We know that the time equals distance over speed. For the first part, the distance, she was running up the hill 300 meters. 300 meters divided by the time. Okay, sorry, divided by the speed. Initially, her speed was 3. So 300 divided by 3 is what? 100 meters per second. So 100 meters, 100 seconds. This is her initial time. What about the second part of the race? The second part of the race, she ran again 300 meters, but this time her speed was 6 meters per second. So to find the second time, time equals again distance over speed, which would be 300 over 6. 300 divided by 6 is 50 seconds. We have two times. We should just add them up. 100 plus 50, 150. So the total distance over total time, 600 divided by 150 would be 4 meters per second. Fine. Answer would be 4 meters per second. Okay? This is how you solve this type of question. You need to find the total time and the total distance. Yeah. Which statement is correct? Which statement is correct? Yeah. I need some answers. Mass is a gravitational force. Mass is a force. No, mass is not a force. Mass is not a gravitational force, and weight is not a, no, weight is a gravitational force. Weight is not. The unit of mass is kilogram. Okay. The unit of weight is the Newton. Yes, this is definitely right. So, okay. Yeah. Question 5. The diagram shows a bird in flight. The bird is flying in a horizontal direction to the right. It's flying to the right. In which direction is the air resistance? If I'm moving to the right, if this is the motion, then the air resistance has to be in the opposite direction. The air resistance it must be in the opposite direction, so it has to be D. Again, if, for example, the bird was moving upwards, then the air resistance would be downwards. If the bird was moving downwards, then the air resistance had to be upwards. Yeah, okay. A measuring cylinder contains 30 centimeters cubed of liquid. Some more liquid is added and the level reaches 50 centimeters cubed. The reading on the balance increases by 30 grams. Again, how should you solve this question? Density density equals mass over volume. Density equals mass over volume. Okay. Or we can just say that it's the difference in the mass over the difference of the volume. The increase in the mass over the increase in the volume. Again, not just any mass and not just any volume. You have to find the difference or the increase in the mass divided by the increase in the volume. So initially, the volume was 30 centimeters cubed, and finally the volume was 50 centimeters cubed. So the difference or the increase in the volume was 50 minus 30. Why? Because it increased by how much? It increased by 20 centimeters cubed. What about the mass? The mass increased by only 30 grams. So 30 divided by 20 is 1.5 grams per centimeters cubed. Hope it's clear. Okay, I hope this question is clear. Yeah, this question is quite easy. Car is traveling, okay, along a straight horizontal road. The speed time graph is shown. Which part of the graph shows a zero resultant force? When the resultant force on the car is zero. When is the resultant force on the car zero? Yes, when the car is moving with a constant speed. When the car is moving with a constant speed, you have a zero resultant force. Okay. Yeah. Next question. Okay. Next question. What is the weight? What is the weight W placed? Okay. What is the weight W placed at the 20 centimeter mark? How can I find the weight? This is a simple moment question. Clockwise moment equals anti-clockwise moment. Clockwise equals anti-clockwise moment. The weight, does it exert a clockwise or an anti-clockwise moment? Yalla, think about it. The weight, is it exerting a clockwise or an anti-clockwise moment? Okay, yes, it is exerting an anti-clockwise moment, but the 6 Newton force is exerting a clockwise moment. Okay, what is the moment? How can we calculate the moment? Force times what times perpendicular distance to the pivot. Again, we have to say that the distance is to the pivot. Okay, force times perpendicular distance to the pivot. So basically the distance between the force and the pivot, the distance between the force and the pivot. So the distance between the W and the pivot is what is 30. I guess this is quite obvious. 50 minus 20, so the distance is what is 30. The other distance, the distance between the 6 newtons and the pivot is 70 minus 50. 70 minus 50, which is 20 centimeters. The clockwise moment would be 6 times 20, and the anti-clockwise would be W times 30. I guess that's quite obvious. 6 times 20 is 120 equals W times 30. We just divide by 30, which would be 4 newtons. Any problems? Any problems? Okay, this is a really interesting question. Actually, it's quite easy. How are the sizes of the forces related? Okay, this rod is now in equilibrium. It's in equilibrium. What are the statements? What are this? Whenever we say an object is in equilibrium, we have to say what? We have to say two things. We have to say two things that yes, the upward forces are equal to the downward forces, yes, and the clockwise moment is equal to the anti-clockwise moment. In this case, we're talking about the forces, so the upward forces have to be equal to the downward forces. What are the upward forces? P and R. They have to be equal to the downward force. So P and R are equal to Q. So P plus R has to be equal to Q. Upward forces equal what? Are equal to the downward forces. Yes. Good. A ball is at rest at the top of the hill. It rolls down the hill. At the bottom of the hill, the ball hits a wall and stops. It hits the wall and stops it. Which energy changes occur? The top of the hill, and then it's falling down, and then it hits the wall and stops. Initially, the ball had kinetic energy. No, initially it had gravitational potential energy. It was at the top of the hill. As it moves down, this gravitational potential energy, it transfers to kinetic energy, and then as it stops, it transfers or it changes into internal energy, such as heat energy, thermal energy, any type of energy. Okay, question 10. 11. Yeah. A man pulls a truck a distance of 20 meters as shown in three diagrams. Which statement concerning the work done against gravity is correct? Most work done in one, no work done in three. The work done in all is equal, while the work done in one and two is equal. How can I solve this question? Yeah. How can I solve this question? Yeah. One. Okay, most work done in is in one. Okay, I think this is right. Okay, it might be right. Let's see. No work done is in no work is done in three. No, this is wrong because definitely the object is moving. So the object moves in three. The work done in all three is equal. I know this is quite tempting. Okay, I know this is quite tempting to say that all of the three in all the three situations, okay, the work done was equal, but it's actually wrong. Okay, why is it wrong? Okay, this is wrong. Why is it wrong? Yeah, Mister, they in all three cases they do move 20 meters. Yes, I know. In all three cases they do move 20 meters, but the problem is in question one, the 20 meters are moving kind of vertically, okay? يعني horizontally and vertically. So basically, he's doing more gravitational potential energy, okay? He's doing more gravitational potential energy. Again, the work done doesn't have to be only in a horizontal motion. It could be in a vertical motion. In this case, it could be in a gravitational potential energy, okay? So in one, okay, in diagram one, he's doing the most gravitational potential energy plus the work done because it is inclined. Yes, because it is inclined. Okay, in question three, you only have 10 meters of inclination, and in question two, you only have diagram two, you only have 10 meters of inclination. But in diagram one, you have 20 meters of inclination. That's why it would be much harder for you. You can think about it, okay? You can think about it. Is it easier for you uh, to push a car, okay, a toy car, for example, or is it easier for you to pull up this car or to remove this car or to push it like 10 meters above uh, vertically? That would be definitely quite hard. That's why question one or diagram one is the hardest situation. Okay? The most work done is in one, is in diagram one. Definitely in one and two are not equal. Okay? I hope this is clear by now. Yeah. Which source of energy is used in a nuclear power station to generate electrical energy? In a nuclear power station. Okay, which source of energy is used in a nuclear power station? Different types of atom regrouping, heavy nuclei splitting, radioactive isotopes decaying, radioactive atoms emitting beta particles. I guess we know it. Okay, heavy nuclei splitting, nuclear power stations, they do split the heavy nuclei such as the uranium. Okay, uranium splits in the nuclear power stations. Good. Question 13. Fusion and fission. Okay. Yes, there is a difference between fusion and fission. There is a difference between fusion and fission, but in the nuclear power stations, we use something called the nuclear fission. And as course students, you are not required to know the difference between the fusion and the fission. We just say that in the nuclear power stations, what happens or what is the energy source or what is the process, we call it the nuclear fission. We call it what? The nuclear fission inside the nuclear power stations. Okay, nuclear fusion, it happens in the sun and the stars. You're not required to know the difference between them, okay? But the simple difference is that the fission, we split, okay? We split the heavy nuclei, such as the uranium. In the fusion, we join the smaller atoms, such as the hydrogen, okay? Again, you are not required to know the difference between them. But on Earth, okay, in the nuclear power stations, what do? We do the nuclear fission, okay? Yeah. We have two beakers. Density of water in is 1000, okay? And then density of oil is 920. In which position is the pressure the greatest? How can I increase the pressure? How can I increase the pressure? Okay. A would be wrong, okay? And D would be wrong. إيه ده? Why is D wrong? Okay. Yes, we need to increase the depth, and we need to increase the density as well. So the density of the oil is less than the density of the water. So you can just cancel out C and D, and definitely we'll cancel out A. So the right answer would be B, increasing the depth and increasing the density. Okay. Manometer is cancelled. Yeah, manometers have been removed from the syllabus. Question 14 is removed. Yeah. Question 15. Question 15. We have yeah, we have a cylinder. Can we repeat 13? Yes, we can repeat 13. Again, how can I increase the pressure? How can I increase the pressure? I need to increase the depth, okay, as you move down, okay, the pressure increases. For example, you're swimming in the swimming pool. If you're on the surface, you don't feel that much pressure, but whenever you go deeper below the surface of the water, what happens? Your ears start to hurt. صح? Why do your ears hurt you? Because the depth has increased and because the pressure below the water has also increased. Whenever your depth below the surface increases, the pressure increases. Again, how can I increase the pressure? I need to increase the density of the liquid. Oil is less dense than water, so the pressure in the oil would be less, okay? The pressure in the oil would be less than the pressure in the water, okay? Okay, yeah. Question 15. A cylinder with a tap contains a fixed mass of gas X. The gas is contained by a piston, which can move freely. Okay, we have this piston which can move now freely. When the tap is opened, we have this tap. When the tap is open, the gas, we have the same mass of the gas. The mass has not changed, but the piston is now moved to the right. Okay, the piston moves to the right. The volume basically increases. The volume increases. Why is this so? Why does the volume increase? Initially, we had some molecules, okay, and the volume was less. When we opened up the tap, okay, when you opened up the tap, the volume increased. Why is this? So, can someone help me out? Or does anyone actually know the answer to this question? Does anyone know the answer to this question? Why did we? Uh, okay, it did reach equilibrium. Yes, thank you. It did reach equilibrium with the atmosphere. It did reach equilibrium with the atmosphere. So before opening the tap, was the pressure, okay? Was the pressure inside the tap greater or was it less? Huh? Yes. Before opening the tap, the pressure was greater. Why is that? The pressure, when the pressure increases, what happens to the volume? The volume decreases. When the pressure increases, what happens to the volume? The volume decreases. As you open up the tap, the volume is now increasing. As you open up the tap, what happens to the volume? The volume is now increasing and the pressure is decreasing. Okay, and the pressure is decreasing. Right. Will the pressure, okay, after you open up the tap, after you open up the tap, will the pressure, okay, I said what I said, that the pressure is now decreasing. The pressure is now decreasing. Will it be less than the atmospheric pressure, or will it be the same as the atmospheric pressure? Again, you said that it would reach equilibrium, which is a perfect keyword. It would reach what? Equilibrium. What do I mean by equilibrium? Hmm? What do I mean by equilibrium? Means, huh? What does it mean? Can the pressure be different now, or does the pressure have to be the same? Pressure has to be the same. Yes, the pressure is the same in equilibrium, in a state of equilibrium. The pressure has to be the same. So initially, the pressure was greater than the atmospheric pressure. Okay, initially, the pressure was greater than the atmospheric pressure. When you opened up the tap, what happened? The pressure started to decrease. And as the pressure decreases, the volume increases. Why is this so? Because the pressure and the volume are inversely proportional, are inversely, proportional. When you decrease the pressure, what happens to the volume? The volume increases. صح? The volume increases. If you have, for example, a balloon and you keep on pressuring and you keep on pushing the balloon towards the wall, for example, or you keep on compressing the balloon, what will happen to the balloon? The balloon will eventually pop. Why? Because you've increased the pressure. So whenever you decrease the volume, the pressure increases, and vice versa. Okay, and vice versa. He didn't say that it reached equilibrium. Yes, I know he didn't say that it reached equilibrium, but it will reach equilibrium. Why? Because you just left it as it should be. Okay. Whenever you have, for example, a balloon, okay, or if you have a can and you open the can, or you have, for example, the room. Okay, if you're sitting in a room, what's the pressure inside this room? It's the same as the atmospheric pressure. Why is the pressure inside the room the same as the atmospheric pressure? Because the air is the same and everything is the same. Okay, it's not a closed environment. Okay, you don't have, for example, a cylinder, or you don't have a solid fixed container in which you can increase or decrease the pressure freely. No, the pressure is now the same as the atmosphere. So whenever you leave the pressure, okay, whenever you leave the tap open, what will happen? The pressure will be the same as the atmosphere. So after opening the tap, the pressure has to be the same as the atmosphere. Initially, the pressure was less, okay? Initially, the pressure was, I'm sorry, was more than the atmospheric pressure, okay? After opening the tap, the same pressure, volume would be smaller. No, the volume initially was smaller. Okay, the volume. Okay, you can see from the diagram that initially the volume was less. Initially, the volume was less. As you opened up the tap, what happened? The volume increased. Okay, the volume increased. This means that initially the pressure was more. The pressure, okay, was greater than the atmospheric pressure. So the answer in this to this question has to be the answer to this question has to be D. Okay. Yeah. Um. Yeah. Question 60. Which quantity? Yeah. Which quantity does not change when there is an increase in temperature? What does not change when there is an increase in temperature. We know that increase in temperature means what? Thermal expansion. صح? Thermal expansion. Okay. Thermal expansion. Thermal expansion increases the volume. It changes the density, which quantity does not change. Does the density? It does change. Okay. The diameter. Okay. It does change. The length. It does change. Definitely. The mass doesn't change. Yes. The mass does not change. Okay. Thermometer and thermal capacity. Both of them have been removed. Okay. Thermometers and thermal capacities. Yep. 17 is cancelled. 18. An experimental thermometer is placed. Okay. How can we find the melting point of a substance? Okay. How can we find the melting point of a substance? Yes, it is the uh yes. Okay. It is the yes, thank you. It is the constant temperature. Okay. The constant temperature. What's the constant temperature in this case? 55, 55, 55. So it's the only temperature that has been repeated. 55. Yes, this is the melting point of this liquid or this whatever substance. Okay, the melting point is 55 degrees Celsius. Why? Because we know for a fact that during the melting point or during the boiling or during the okay, melting, boiling, freezing, condensation, whatever, they all happen at a constant temperature. The water, for example, keeps on boiling at 100 degrees Celsius for some time. Okay, the ice keeps on melting at 0 degrees Celsius for some period of time. Okay, so if you keep on measuring the temperature of melting ice, okay, if you measure the temperature 3, 4, 5 times, as long as it's still melting, the temperature will remain constant at 0 degrees Celsius. For this question, for this substance, the melting point was 55. Why? Because it kept on repeating at 55. Okay, yeah. Question 19. Question 19. A teacher demonstrates an experiment to a class. Okay, we have a tube of water. Okay, and when she applies the heat, okay, she applies the heat to the top of the water. Okay, she tilted, uh, she tilted this testing tube or whatever. Okay, a bit, and then the heat was applied only to the top of the water, only to this part, only to this part. What happens? The top of the water boils. Top of the water starts to boil. Yes, the top of the water starts to boil, but the ice does not melt. Why is this so? Hmm. What does this demonstrate? Okay, the top of the water starts to boil, but the ice does not melt. Okay, okay, let's cancel out the wrong answers. Water is a good conductor of thermal energy. No, this is wrong. Water is not a good conductor. Water is a good convector of thermal energy. Hmm. Water could be a good convector. It could be a good convector of thermal energy. Water is a poor conductor of thermal energy. Okay, it could be a poor conductor of thermal energy. Water is a poor convector. No, actually, water is a good convector of thermal energy. Type. Convector means that you could have convection currents, okay? That the hot water could rise up and the cold water could fall down. So yes, water and gases are both good convectors, okay? Type. What does this experiment demonstrate? Is it that the water is a good convector, or is it that the water is poor conductor? Why does the ice remain solid why does the ice not melt? Why is only the top surface? Why is this part only boiling, but the ice is unaffected? Huh? Is it due to convection? Is it due to convection? Actually, not. Why? No. Why? Because this part is hot and this part is cold. We know, we know for a fact, in convection, the hot rises up. The hot rises up and the cold falls down. In this case, the hot is already at the top and the cold is already at the bottom. So would they actually want to move? Would the hot, for example, would the hot water, for example, want to go down and the cold water want to move up? No, the hot water would want to remain at the top, okay, at the surface, and the cold water would want to remain at the bottom. They will remain unaffected, okay? They will not move. The boiling water would remain at the surface, and the cold ice, the cold water would remain at the bottom. So both of them wouldn't move. So in this case, we cannot say that the water is a good convector. In this case, we only have to say that the water is a poor conductor. Why? Why is water a poor conductor for this question? Because this is the hot part and this is the cold part. We know that the hot part should start to heat up the cold part due to conduction, due to the lattice vibration of the molecules. The molecules should start to vibrate, okay, and collide with each other, and thus conducting the heat by lattice vibration. But we know that the conduction, okay, it's the worst in liquids and gases. The conduction is best only in solids. Conduction is best only in solids. In this question, this is liquid, and we know that liquids are poor conductors. We know that liquids are what? Are poor conductors. We cannot say that water is a good. When could we say that water is a good conductor? If we applied the heat, if we applied the heat from the bottom. If you did apply the heat from the bottom, yes, you would have said that the water is a good conductor. But for this question, you only applied the heat from the top. And when you applied the heat from the top, the heat would not transfer to the bottom. Why? Because the hot water wants to remain at the top and the cold water wants to remain at the bottom. Okay. Rises, well, the heat is already at the top. Again, I just said it, the hot water is already at the top. It does not want to go down. Okay, it would not be able to go down. Why? Because the density, because of its density, the hot water has less density, which would make it, okay, it will remain at the top surface. Okay. Okay, yeah. Question 20. A hot metal plate is placed near to a cold plate. Infrared radiation transfers the thermal energy. Infrared radiation transfers the thermal energy between the two plates. Okay, between the two plates. Which choice of color causes the temperature of the cold place to increase most? Okay, to increase most slowly. We need the cold plate to increase the most slowly. Ha, yes, great. Perfect. Yes, it is shiny white and shiny white. Why? Why shiny white and shiny white? If the hot plate was shiny white, it would have been the worst emitter. So it would give off radiation, it would give off heat, but at a very slow rate. If the cold plate is now shiny white, we would call it not the worst emitter. In this case, it would be the worst إيه بقى؟ worst absorber. صح, the worst absorber. So it would absorb energy, but at a very slow rate. Okay, the worst absorber. So the shiny white and shiny white would definitely make the cold plate increase, okay, the most slowly. Quite easy. Question 21. Which row shows an example of transverse, okay, of a transverse wave and an example of a longitudinal wave? يلا, transverse and longitudinal. Quite easy. Hmm, Okay. Okay. A lot of you would be tempted to say A. صح. Could you say A? Is A right? Can I say that the transverse is light? Yes. Light waves are transverse waves. Are radio waves longitudinal? Huh. Are radio waves longitudinal? Actually, not. Radio waves are part of the electromagnetic spectrum, which are not longitudinal. The electromagnetic spectrum is transverse. Okay, B, radio waves. Yes, they are transverse. Sound waves, are they long? Yes, they are. So question B is, okay, answer. B is the only correct answer. Sound is longitudinal and water waves are transverse. Water waves يا شباب, they are transverse waves. يلا, I have an object and I have a mirror. Where does she see the image? How can I see the image of this object? How can I see the image of this object? Is it in at A, B, C, or D? It's quite obvious. يلا, is it A, B, C, or D? Hmm. Okay. You can use a ruler. You can just use a ruler to find the distance between the object and the mirror, and the same distance would be all the way to D. That's it. Okay? It's not C. C is wrong. Okay? The same distance from the object to the mirror would be to the from the mirror to the image at D. Yes, great. Question 23. Light passes through a prism. Which term is used to describe the production of the spectrum of colors? The production of the which term is used to describe this spectrum of colors? Diffraction? Definitely it is dispersion. It's definitely. No, it's not refraction. No, refraction is wrong. Okay. This is called dispersion to produce the spectrum of colors. Yes, to produce the spectrum of colors, it would be um It would be dispersion, yes. Which type of waves are produced by television remote controller? Yes, a remote controller. Hmm. F visible light, ultraviolet. Definitely, they are the infrared, صح? You know, remote controllers use infrared. Both the amplitude, يلا, both the amplitude and the frequency of a sound wave decrease. When you decrease the amplitude, what happens? And when you decrease the frequency, what happens? When you decrease the amplitude, hmm, the wave, okay, the sound is quieter. Yes. When you decrease the frequency, the pitch is lower. Yes, it is D. Yes, it is D. Help. An electromagnet is used to remove a splinter from an eye. A splinter, you have small object in your eye. Which material is the splinter made of? The splinter, okay, is now removed using an electromagnet. Huh. It has to be made of iron. Definitely, yes. It has to be made of iron. Quite easy, huh? Hmm. Which diagram shows the magnetic field around the bar magnet? Huh. يلا. Magnetic field around a bar magnet. Okay, okay. Huh. حلو. يلا, all of you are correct. Can A be correct? No, it's wrong. Why? Because the magnetic field can't be going into the North Pole. This is wrong. Okay, is B correct? Yes, it's going outside, but it cannot go outside the south. It would be wrong, huh? Out of the north into the south and from the north to the south. Okay, so this is definitely correct. Yes, C is the right answer. Yep. A metal conductor is connected to a battery. Which statement describes the current in the metal conductor? Huh. The metal, the current inside this metal conductor, again, the current inside this wire, the current inside this wire. How's it moving? How is this current moving? Hmm. Flow of, hmm, can it be the flow of protons? Cannot be the flow of protons. Has to be the flow of electrons. From the positive to the negative or from the negative to the positive? Okay. This is a rather difficult question. And you, as core students, aren't actually required to know this answer. Type, why do you have this question? Again, March uh, question papers, okay, March usually includes some of the extended questions. March usually includes some of the extended questions. You will not be you will not have actually these questions. Okay, you will not be required to know this answer, this specific answer. You will not be required to know this specific answer. Why? Because actually the electrons flow from the negative to the positive. إذا يا مستر احنا we know that the current moves from the positive to the negative. Yes, that is correct. The current moves whenever I say the current, okay, the direction of the current, it moves from from the positive to the negative. But if he asks about the flow of electrons, they move from the negative to the positive. But will you be required to know or to answer this question in your exam? Okay, no, you will not be required. Only if you're planning on entering one of the March exams, okay, you might be asked a question similar to this one. Okay. Other than that, no, you will not be required to answer this question. Why? Because this is an extended question. This is not, okay, again, I am repeating myself. This is not a core question. Okay. I'm very clear. This is not a core question. When do you say from positive to negative? If you were asked about the direction of the current. Okay. The current itself. The current moves from the positive terminal to the negative terminal. The current itself, whenever I say, what's the direction of the current, it's moving from the positive to the negative. But whenever I say the direction of the flow of electrons, huh, the direction of the electrons themselves, they move from the negative to, again, you are not required to know the difference between them. Okay, you are not required to know the difference between them. Yep. A student sets up the circuit shown. Okay, he needs to measure three quantities: the current, the electromotive force, and the potential difference across the lamp. How many ammeters and how many voltmeters are needed? حلو. Okay, a very easy question. needs to measure three quantities: the current in the circuit, the electromotive force, and the potential difference. Okay, the current. I need an ammeter. Do I need zero ammeters? Definitely not. Huh? One, two, or three? Yes, I need only one ammeter. So this is the answer. Yes, this is the answer. You only need one ammeter. Why? Because if you put this ammeter at any position in the circuit, it would give you the total current of the circuit. You need two voltmeters, one, okay, for the lamp and the other one for the battery, okay, or for the cell. Yeah. Question 30. What's the resistance of the lamp when it is lit? How can I find the resistance? Very easy. R equals, yeah, V over I. Yeah, V over I, 12 over 3, which is 4 ohms. Now, question 31. The resistance, okay, of the variable resistor is increased. You increase the resistance of this variable resistance. What happens to the current and what happens to the lamp brightness? When the resistance increases, we know that the current decreases. Okay, this is quite simple, quite obvious. We know that the resistance, as the resistance increases, the current decreases. What happens to the lamp brightness? When the resistance of the variable resistor increases, the voltage or the potential difference increases. Type. When the voltage or the potential difference increases of the variable resistance, what happens to the voltage of the lamp? What happens to the voltage of the lamp has to decrease. Why? Because you only have, it's a cell, okay? It's a battery, okay? Provides a constant voltage, okay? So the voltage has to be divided between the variable resistor and the lamp. If the voltage of the variable resistor increases, then the voltage of the lamp will decrease. When the voltage of the lamp decreases, then the brightness of the lamp also decreases. Again, the voltage and the brightness are directly proportional. The voltage of the lamp and the brightness of the lamp are directly proportional. So the ammeter reading will decrease and the lamp brightness also will decrease. Okay. Yeah. Question 32. Which statement is correct? We have two diagrams. Okay. Oh, well, again, 31. What's the problem with 31? Again, R increases, as the resistance increases, what happens to the voltage? The voltage increases. But when the voltage increases, for example, the voltage was 12 volts. Initially, they both had 6 volts. If the voltage of the potential of the variable resistor increases, this would be 9 volts, and the voltage of the lamp would be 3 volts. So the voltage would decrease. When the voltage decreases, the brightness decreases. The brightness does not increase. No, the brightness has to decrease. Yeah. Question 32. Which statement is correct? We have two diagrams, 1 and 2. 1 and 2. Yep. I need some help with this question. Diagram 1 shows two identical lamps. They are in series. Diagram 2 shows them, but they are in parallel. The cell in diagram 1 can supply current to the lamps for longer than the cell in diagram 2. The current in the current in the cell in diagram 1 is greater than the current in the cell in diagram 2. The lamps in diagram 1 are brighter than the lamps in diagram 2. The voltage across each lamp in 1 is greater than the voltage in diagram 2. Let's cancel out the wrong answers. Again, let's cancel out the wrong answers. The voltage in 1 is greater than the voltage in 2. No, actually, this is wrong. Why? Because in 1, what happened to the voltage? It was divided. The voltage was divided. The voltage in diagram 2 was not divided. For example, if this was 12 volts, all of them, okay, would receive also 12. So this is definitely wrong. The lamps in diagram 1 are brighter than the lamps in diagram 2. Again, it is wrong because as the voltage was divided, for example, this is 6 volts and this is 6 volts, okay, each of them receive only 6 volts, so the brightness would decrease. They would be a bit dimmer. They would be a bit dimmer. Um, okay, the current in cell, okay, in diagram 1 is greater than the current in diagram 2. In diagram 1, you had both of these lamps in series. صح? in series. طيب when they are in series, what happens to the resistance? You just add up the resistance, and the resistance increases. When the resistance increases, what happens to current? The current decreases. So this is wrong as well. This is question. The answer has to be yes. The answer has to be A. Okay. The cell in diagram 1 can supply current to the lamps for longer than the cell in diagram 2. Why? We just said that the current is less. Okay. The current in diagram 1 is less. Diagram 1 is greater. No, this is wrong. Okay. It has to be less. Why? Because the resistance is more. Okay. You have an increase in the total resistance. You have an increase. Again, why is B wrong? Again, let's cancel out B. The current in the cell in diagram 1 is greater than the current in diagram 2. No, this is wrong. Why? Because in diagram 2, you have both of them in parallel. What happens when you have two resistors or two lamps in parallel? What happens to the resistance? Okay, what happens to the resistance? The resistance decreases. But when the resistance decreases, what happens to the current? Huh? The current increases. Current increases. So B is wrong. The current in cell 1 is great. No, the current in cell 1 is less. Current in cell 1 has to be less. Okay. Why? Again, because we added up the resistors. For example, if this was 10 ohms and the other one was 10 ohms, so you just add up the resistance, total resistance would be 20 ohms. Okay. When you increase the resistance, the current decreases. When you increase the resistance, what happens to the current? The current decreases. That's it. So in diagram 1, the resistance was more and the current was less. But what about the answer? A. The cell in diagram 1 can supply current to the lamps for longer than the cell in diagram 2. Yes, it can supply current to the lamps for longer. Why? Because it gives off less current. Okay, we have this is the positive term and this is the it will supply, okay, a current for a longer time. Why would it supply a current for a longer time? Because the current is less. You can, if you want to think about it, if you want to think about it, power equals VI. If you decrease the current, okay, then you will decrease the power and you can take more time. Okay, again, I don't want to just okay, just forget about this. Okay, just forget about this. Okay, again, if you decrease the current, then the battery will be able to to switch on both of these lamps for a longer time. Okay, for a longer time. That's it. Okay, I hope it's clear by now. Hmm. Yeah. Question 33. This is easy. Okay. This is easy, very easy actually. Which ammeter shows the largest reading? Which ammeter shows the largest reading? Yalla, this is very easy, honestly. D, definitely. It has to be D. Yes, definitely has to be D. Why? Because it's the one nearest to the uh, cell or to the battery whenever the current, uh, whenever you have a parallel circuit, whenever you have a parallel circuit, what happens? Okay, the current gets divided. So A is less, B is less, and C is less. D is the greatest current. Okay, D is the greatest current. Okay, yeah. Question 34, okay, might be a bit tricky. Okay, question 34 might be a bit tricky. Why is okay, why is question 34 a bit tricky? The diagram shows the arrangement of a coil, an armature, okay, and contacts of a relay. Which diagram shows this arrangement when there is no current in the coil? Okay, when there is no current in the coil. Okay, when there's no current in the coil, you have this coil with no current, so it will not be magnetized. صح? This coil is now not a magnet. This coil is now not. So it will not, again, it will not attract the armature. This armature is made of iron. This armature is made of a iron. So if there was a current in the coil, this armature would have been attracted, okay? This iron armature would have been attracted to the coil, صح? It would have been attracted to the coil a little. And there's a pivot, okay? So it can freely move around this pivot. It can freely move and rotate around this pivot. Type. Which of these diagrams could be correct? You need, okay, you need the coil. Okay, now the coil is not a magnet. Let's cancel out some of the questions, or let's check them out. Question in answer A. Okay, in answer A, there's no current in the coil. So the coil is not a magnet. Is the pivot or is the iron armature attracted to the coil? No, it's not attracted to the coil. Okay, it's not attracted to the coil. And the armature is, okay, facing downwards, which is correct. ايه ده? How is this correct? Okay, I'll show you the wrong answers. I'll show you the wrong answers. In B, okay, in B, there's no current in the magnet. There's no current in the coil. Okay, so this pivot actually should be facing a bit downwards this way. Okay, this armature should be facing a bit downwards. Why? Okay, why is it now? The question is, why is it now attracted? Okay, there's a slight difference. Okay, there is a slight difference between A and B. If you can compare, okay, A and B, you'd find that B is slightly attracted to the coil. Should it be attracted to the coil? No, it should not be attracted to the coil. It should be free to move. It should be actually falling downwards a bit. Okay, it should be falling downwards a bit as in A. So B is wrong. Okay, B, it shouldn't be. Okay, it shouldn't be facing upwards. Okay, in C, in C, it's falling, okay, and now, but the problem is, okay, C could be right, okay, C could be right, but the problem is when the armature is facing downwards and the contacts are now touching the other circuit, whatever circuit is on the other side is now operating. The other circuit uh, is now there's a current in the other circuit. Should there be a current in the other circuit? No. There shouldn't be a current in the other circuit. Okay? There shouldn't be a current in the other circuit. That's why C and D have to be canceled out. Okay? If you see this question, what should you do? You should cancel out C and D. Why? Because there shouldn't be a current in the other circuit when there's no current in the first circuit, when there's no current in the coil. For example, this is the coil, it's connected to a switch and a battery. Okay, if there's no current in the coil, if there's no current in this circuit, then there should be no current in the other circuit as well. So in C, no, this is wrong. Okay, you do not want a current in the other circuit. Okay, so C and D have to be canceled out, and as we said, B is now canceled out. So the only answer would be A. The only right answer would be A. Again, this is a rather difficult question. Okay, it is a rather difficult question, and it's okay if you feel that it's a bit hard. This is very, very normal for the March questions. Okay, the February March questions. This is very normal for the February March questions. Okay, so it's not a problem in you. Okay, you've done, يعني, you have studied enough. Okay, it's not a problem in you, it's a problem with the actual questions, the actual February March questions. Okay, do not worry, please. Let's solve this question. Okay, let's solve this question. Question 35. What causes this field? There's a magnetic field. There is a magnetic field. Huh. What could cause this shape of the magnetic field? A bar magnet? Could a bar magnet cause this field? No. A solenoid carrying a current. A solenoid carrying a current? No. It would actually cause, okay, a magnetic field quite similar to the bar magnet. Quite a little bit similar to the bar magnet. A straight wire carrying current? Yes, a straight wire carrying the current. A straight wire carrying the current. And actually, in this case, for this question, the current would be going into the page. The current would be going into the page. And I can explain this further on, later on. Okay, not now. Okay, but for this question, there is a current, there is a wire carrying a current, and this current To be very specific, it's actually moving into the page. Yeah. Um, Question 36, diagram shows a simple DC electric motor which change, okay, would make the motor rotate more quickly. Yes, we need the motor to rotate more quickly. Any ideas? Any ideas? How can the motor rotate more quickly? Hmm. Okay. Can I reverse the polarity? No, if you reverse the polarity, it will move in the opposite direction. Can I reverse the battery? Again, it will rotate in the opposite direction. Can I remove the magnets? If you remove the magnets, it wouldn't rotate at all. Hmm. The only right answer would be increasing the number of turns on the coil. Yes. You could increase the number of turns, you could increase the current, and you could increase the strength of the magnetic field. Yeah, question 37, very easy question. Composition of this sodium isotope. How many protons, neutrons, and electrons do we have? Ah, again, this is very easy. The number of protons would be 11, and the number of electrons has to be 11 as well. Number of neutrons would be 23, okay, minus 11, which is 12. Super easy. Yeah. Which diagram represents the nucleus of H3 and 1? H hydrogen, which is quite easy. H3 and 1. Hmm. What is 3 and 1? 1 represents the number of protons, 1 protons. 3 represents what? Represents the total mass number. Okay? The mass number is 3, so we can cancel out C and D. صح? We can cancel out 3, C and D. What is the number of neutrons? Number of neutrons would be 3 minus 1, which is 2 neutrons. So we have 2 neutrons and only 1 proton. Yeah. Question 39. When measuring the emissions from a radioactive rock brought to the laboratory, a teacher mentions that background radiation must be taken into account. What is the background radiation? What is the background radiation? Yalla. Infrared radiation from warm objects? لا. Infrared radiation from the sun? No. Again, it's not infrared radiation at all. Also, ionizing radiation from the radioactive rock brought into the laboratory? That wouldn't be that wouldn't be a background radiation. The background radiation, okay, would be the radiation when the radioactive rock is not present. It's the radioactive radiation, okay, it's the radiation that's already present, that's already there without bringing in any other radioactive sources. Yes, 39 would be D. 39 is D. Yep. Question 40. A very simple question now. A student measures the initial rate of emission as 40,000 emissions per second. How long does it take for the emission to fall down to 5,000 emissions per second? Right. What should we do? First of all, you need to find the half-life. First of all, you need to find the half-life. How can I find the half-life from the graph? Quite easily. Okay, what do I do? 100%. This is 100%. 100%. Divide by 2. 100% divided by 2 is what? Divided by 2 is 50%. So using the 50%, we can find the half-life to be 5 minutes. Half-life, okay, is now what? Is now 5 minutes. It's now 5 minutes. This is the half-life. Most of you would be tempted to just choose A. Again, this is not the answer. A is wrong. He is not asking about the half-life of this isotope. He's asking how long will it take for the 40,000 to drop to 5,000? What should we do? We should just keep on dividing by 2. 40,000 divided by 2 is 20,000. Yeah. Again, divide by 2, 10,000. And when you divide by 2, it would be 5,000. What did we do? We divided by 2 3 times. So we used up 3 half-lives. Yeah, we took 3 half-lives. Each of these half-lives is 5 minutes long. So 3 times 5 would be 15 minutes. 3 times 5 would be 15 minutes. Okay? Okay.